Hello, everyone. Welcome to the Introduction to SQL webinar hosted by UCLA Extension. Just want to remind everyone that if you are not asking questions at the moment, if you can please mute your speaker or your phone, and that will reduce the echo. Okay, all right. So let's get started. And again, welcome. And what we're going to be doing is that basically that we will use this opportunity and to give you an overview of SQL. And my name is, let's see if I can move to the next slide. Okay, my name is Bruce Huang, and I am the director of the Digital Technology Department here at UCLA Extension. And we also here we have Venise Crawford, and she's the program manager for the computer science and information system programs within the Digital Technology Department. And so what we're going to be doing today in the next 45 minutes or so, and we will be talking about SQL and give you an introduction to SQL. And then when we get done with that, we're going to do a quick Q&A session. If you have any questions that we want to help you and get the answers to you. And if you wanted to send questions to us throughout the presentation, you can use the chat function. And you can type in the chat, and I will be monitoring those questions as well. Okay, and after that, and we're going to be basically giving you a little bit more information on the related UCLA extension courses and certificates, and give you a little demo on where to look for those informations, and as well as enrolling for the courses. I want to introduce to you today that we are so lucky that we have one of the UCLA extension instructor here with us, and his name is Han. And Ray will be the presenter, and he will be taking you through the introduction for SQL in the next 45 minutes or so. Ray is a graduate of Yale, and with a bachelor's degree in the applied math and computer science, and he has a systems engineering master from Stanford. And Ray is also one of our very own and alumni of the UCLA extension here that is a certificate holders and etc. He has worked for a number of the companies in the industry, and they're currently on the board of 3 startups of the internet startups. So what I'm going to do now is basically I'm going to turn over to Ray and enjoy the session.
Okay, my name is Ray Han. I'm going to be an instructor for SQL, Advanced SQL, and databases. I'd like to say, well, first of all, why would you even want to learn SQL? And, well, for one thing, it's according to the computer world, the list of IT skills in demand, SQL is actually #1. What is SQL? It's a structured query language, and it's at the heart of all relational database languages and database management systems, including IBM, DB2 Oracle, Microsoft SQL Server, and MySQL. Where did it originate? How did they find SQL? Who created it? Well, SQL had its origins in the relational model from a paper written by Dr. Edward Codd, developed at IBM in 1970. However, it was Oracle, which is a company I worked for, which introduced it in 1979 as a SQL relational database management system. This is the brief history of SQL. Maybe not so brief. It's been around for 30 to 40 years, and it's still going strong. 1970 was when it first started. 1970 highlighted dates. 1979 was when Oracle took SQL and created a whole company out of it. In 1987, Microsoft got into it and developed SQL Server. Okay, what is it used for? Well, SQL is devised for manipulating data in a database management system through tables. It handles roles through data types, and it is a national standardized through ANSI and ISO. What makes it so special? Well, SQL provides the exchange and integration of data from different sources. There have been a lot of different languages and a lot of different databases, but SQL is still there, very high demand. The skills you learn from SQL carry over to other languages and other tools for RDBMS. Where is it used? Almost everywhere you see a database, relational database, for support and administration. What system does it run on? Well, SQL has different dialects. For the desktop, it's different than for Unix. For instance, for Sun, it has SQL-J for the Java language. What is coming up? Well, SQL and XML integration from WW Consortium has IBM and Oracle already implementing a version of this, and Microsoft promises new extensions. Okay, I wanted you to, in your own time, I want you to do a Google search. Look at Indeed, which is a job network board. Do a search on SQL jobs in Los Angeles, California. You can do a SQL search for anywhere in the US, but in Los Angeles, I got 88,978 new searches. Now, I looked in particular, I saw this is pretty fascinating. A junior analyst in Los Angeles, California, there's a job posting for $151,000 a year for SQL for a high-tech company. Okay, so learning SQL can be one of your greatest career decisions you ever make. Beyond the potential salary, there's no longer relying on others to give you information. You have to be able to ask your own questions about your business. So if you want to find out information about almost anything through a database, you can use SQL to get it. Average SQL developer salary, according to Indeed, was $92,000. Remember, this is average, so there's room for the upward bound is even higher. The median household income for a household for people is only $52,000, and you see one SQL developer averages $92,000, and there's a shortage of people. Now, what can you do with SQL? Well, you can ask questions like, what were our sales last year? What is our average customer satisfaction rating? At what rate have we reduced expenses since last summer? These are questions that can be answered using SQL, and you don't have to rely on pre-built Excel reports anymore. Excel is a spreadsheet which allows you to store information, but SQL databases store millions and millions of rows of data. They allow you to perform operations on vast amounts of data without having to worry about crashing a program. SQL queries can be saved like Excel spreadsheets and reused at any point. SQL code can also be edited with comments so you can remember what you did. Everyone should learn SQL. SQL is an incredibly important and valuable skill employers desire. So much of our business is digital now. Digital means data. Data means databases. And to access these databases, you need SQL. SQL is used in banking. You know, when you update your transactions, you use SQL. Airlines, when you make a reservation, schedule a flight, again, SQL. Universities, registration, grades, again, SQL. Sales, customers, products, purchases, online retailers, manufacturing. Human resources, employee records, again, finding the information is done through SQL. Financial analysts on Wall Street, where the salaries go really way into the 100,000s. There's a lot of use for SQL. Even financial analysts who are not tech engineers, they need SQL too. They need it for financial modeling, planning, forecasting, calculating commissions for brokers, updating data if any instrument's value changes. Roles which require SQL, there are four main roles: back-end developer, database administrator, data analyst, and data scientist. Okay, now fundamentally, SQL Server, when you have a database management system, you have a server where the database is, where it's dedicated to the database. And then clients on individual computers access that database. So when you have database server, so when you have SQL Server, you have the database on a server, and you have clients accessing that server. Okay, so you see this in the clients, and then the network connects you to a database server. The queries are performed to the server, and the results are replied down to the client. So server software is back-end processing, client software is front-end processing. And there's a SQL interface, and you can design that customize that according to what you want. Okay, so with application server, you go through the application server, then through the database server. With the web server, you go through a web server, then the database server. Okay, now when we work with, in our particular case here, we're talking about SQL Server as opposed to like Oracle or MySQL or DB2. With SQL Server, you start working with the Management Studio, and it allows you to connect to the database, and it can also help you design queries and backups and store security information of the database. Okay, and to log on to SQL Server, you have to do authentication and attach the database, and it's attached to it's put into a default directory. You can perform queries with the Query Designer. Okay, so just briefly, why SQL Server? Well, SQL Server interacts easily with Microsoft operating system Windows because it's built by Microsoft. Easily integrates with Excel. It has a friendly user interface and easy to create maintenance plans. Security is tight, and there's mixed authentication, disaster recovery is easy. Licensing is flexible. We talked about SQL Server Management Studio. Administration, backup compression, data encryption are very strong. Okay, so SQL and relational databases. Here is how fundamentally data is stored with SQL. You have a table. A table is the structure of information. For instance, this is a vendor table, someone who sells something. And every table must have a primary key or unique ID that separates the rows from one another. So the vendor ID will be 1, so that's unique. 1 is a record, 2 is a separate record, 3 is another record. Number 1, the vendor name is U.S. Postal Services, and the fields are address and vendor city. Okay, so, well, you see, you have vendors, right? But what good is vendors? Well, you can get vendor information, but sometimes vendors are related to other entities or tables. For instance, the invoice. You have vendors and you have invoices, and how do they connect? Well, you can connect information from both tables by joining the tables together and getting information from both of them. Now, how do you do that? Usually what you do is you take a primary key and you match that up to the other table and put that into the other table, which that becomes a foreign key for that second table. It's the primary key in the first table. Now, when you do that, you can join the tables together and get joint information. There are 3 main types of relationships between tables: one-to-many, one-to-one, and many-to-many. Okay, so each field in the table must have a data type. You can have integer, you can have money, dollars, decimal, floating point, or character. Okay, so here's the table. First of all, we have to create the database AP, and then we create the table invoices. Invoice ID is an integer, so you have INT. In the third column, you have not null, which means you have to, this is a constraint, which means you have to have a value there. If this invoice ID has to be filled with a value. And then you have vendor ID, which is actually referencing another table. So it's the primary key of another table. Invoice number is varchar character. Invoice total is money. And terms ID also references another table. Okay, so basically with SQL, you can perform different action, interact differently with the table. You can even actually alter the table to add another column. And that's altering the table invoices. You add a balance due, which is of type money, and you have to have something there. You can also delete a column by altering the table invoices, dropping the column balance due. And indexes allow you to access records in a specific way. Okay, so here we have a query. What are we returning in this query? The results is a select statement, which I will go through a little bit later. Most queries begin with a select statement. So you want to select the columns: invoice number, invoice date, invoice total, payment total, credit total, and you have a last column, which is invoice total minus payment total minus credit total, which is actually you rename as the balance due. This is from the table invoices, and you want a particular condition where the balance due, which is invoice total minus payment total minus credit, greater than 0, where you owe something, and you want to order it, sort it by the invoice date. Okay, and this is your result. Okay. Now to add new information to the table, you do an insert into. So you insert into the table invoices with the variance field, and then you add values, and that populates the table. This is difficult to read. A select statement is difficult to read. Let's move on. Okay, select statement. Now you can comment your select statement so you remember what you did. Okay, now remember when we join the two tables together, we have information from one table, information from a second table, and we want to gather information from both tables. What we do to get both tables, the information from both tables, is we do a join on a condition. So you select a column from the table 1, joining table 2 on the join condition. Okay, so we select invoice number, vendor name from the two tables. So vendor table is joined with invoices on the vendor ID, and this is your result set. Okay. Some coding recommendations: start each new line search each new clause on a new line, break long clauses into multiple lines, capitalize the first letter of each keyword, and each statement with a semicolon. Use comments only for difficult to understand portions of the code. Okay. Okay. So, okay. You know, I mentioned that database management systems can be used for a wide variety of applications: banking, airlines, universities, sales, manufacturing, human resources. Databases can be very large. First, we can have a university database to add new students, instructors, and courses. Now, notice that these two would probably be different tables. Students is one table, instructors is a table, and courses is another table, and you can interact to get information coming from either one, two, or all three of them. Register the students for courses, generate class rosters, assign grades to students, complete grade point averages. Okay. Data models. Okay, this is just talking about like how the tables are organized. You have a relational model, which just means tables. Now you have something called a diagramming. We have diagramming these flows of information together. That's called entity relationship diagramming. It's where each table is an entity. The table relates to another table, and you can like connect them through a line. And then when you do this, some programs let you automatically convert the entities that you draw into tables. And also, let's see, there are newer type of databases which extend from relational, like object-oriented and object-relational. And you can also work with the traditional popular scripting language, XML. Okay. So here again is a table, instructor table, ID, name, Einstein, department of physics, salary. You have an instructor table, department table. Okay. Okay. So we talk about SQL in two different ways: as a data definition language and as a data manipulation language. A data definition language means creating the tables, dropping the tables, basically defining things. So when you create a table, like instructor, you want to give the ID, name, department name, salary, and the fields. And their integrity constraints, you know, you have a primary key as the ID, and you might say salary cannot be lower than 0. That's a constraint. Okay. Data manipulation language means moving or altering the data, moving or getting the data. Accessing and manipulating the data is done as a data manipulation language. Now, SQL is actually, it's a language, but it's not like C++ or Java. So in a sense, it's not a Turing machine equivalent language. It means you can't make games out of it. It's only done for database scripting. Okay? But applications can use SQL within the program. So you can have Java and C# use SQL to do the database scripting, but then you have to connect Java or C# through a driver, which should be ODBC or JDBC, to the SQL database. Okay. I talked about entity relationship modeling. Now, when you make a table, well, what determines when you stop making, well, how big the table is? The table could be 10, 20, 30 columns. Now, there's something called normalization theory, which tells you where to stop the table. And it allows, so you don't want to be too redundant. And there's several things we'll talk about in class, if you take my class, about normalization there, where it tells you where to stop designing the table. and truncating it and making another table or another third or fourth table after that. Okay, data definition language. Okay, all right, so creating table, create the table and the table name and the fields and the constraints. You see here, the primary create table instructor, you have a primary key ID, and you have a foreign key department name references another table department. Okay. And you can update tables, you can insert table into the tables, you can delete from the tables, you can drop the table. Dropping the table is different from deleting from the table. Deleting deletes a record, drop table just erases the whole table. Altering the table means you add fields to the table. Okay, and this is perhaps the most important syntax code for a SQL. It's the select statement. This is how a query begins. When you use select, you get information from the database through a query. Query is like how old is the student, what's the GPA, what's the person's salary. You get that information by querying the database. That's done through a select statement. So select, what do I want? What attributes do you want? What columns do I want from which tables, where, according to what conditions? The select clause lists the attributes desired as a result of a query. Find the names of all instructors. Select the name from the instructor table. Now, the select statement is giving you everything. Now, if you only want to, like if you pull up everything, you can pull up, when you pull up the table, you get everything. You get department name, and the department name might be repeated. So if you only want a department name once from the instructor table, you'd have to do a distinct operator. Okay, so let's look at this. Select star from instructor. What do you think that does? That gives you every column from the instructor table. And then you can select from a particular column from the table, and that will be in your results set. Okay, select ID, name, and salary divided by 12 from instructor. And what would that give you? That'll give you the ID, name, and salary divided by 12. You can select name from instructor. So the name is the column, the table is instructor, and the condition is we want the instructors for the computer science department. So that'd be where department name equals comp sci. To find all instructors in comp sci, department with salary greater than 80,000, we would get the name, select name from the table where department name equals comp sci and salary is greater than 80,000. Okay. Let's move on. Okay. Let's say I want to select the name of instructor and his name is David. Now David could go by Dave, right? So how would I do that so I can not only get David but Dave? Well, that's where you use a string operation. So select name from instructor where name is like %DAV percent or just DAV percent. That'll give you Dave. That'll give you DAV, DAVE, DAVID. Okay, does that make sense? Okay.
Yes.
Now, when you get back the query, you can order the query, sort the query. You can descend. You can do a descending order or ascending order. Order by the name you want to sort on. Okay. Now, there's also various other commands you can use within select from where. Let's say you want to select the name of the person who's an instructor whose salary is between 90,000 and 100,000. So you would just select name, which is a column you want, from the table instructor where the salary is between 90,000 and 100,000. Okay, and you can find courses they're in fall 2009 or in spring 2010. You can put them all into one table as a result set. You can find courses they're in fall. I think that's a duplicate there. Okay, for some reason. Okay, so you could do union, you can do intersection of tables, you could do except. Okay, no values. I think I mentioned earlier, sometimes no values are not allowed. Sometimes they are allowed. No value means nothing is there. So maybe an instructor just started and he has no salary yet. Select name from instructor where salary is no would give you the name of the instructors who have not been assigned a salary yet. Now, there are some things called aggregate functions, which are a little bit different for the select clause. For instance, you might want to find the average for a list of values, or minimum, maximum, sum, or count. This is done through aggregate functions. So let's say I want to get the average salary for all instructors in the computer science department. I would select average, salary, the column from the table under the condition where department name equals computer science. You can actually also count the number of teachers who teach in the spring of 2010. You would select count distinct ID from teaches, which is a table where semester equals spring and year equals 2010. To find all the number of tuples in a course relation, you would do a select count star from course. Okay, so what do we have here? We have a query, a select statement. We want the department name where the average salary is from instructor grouped by department name. So you have biology, computer science, electrical engineering, finance, history, music, physics, all grouped together. Okay. Now you can actually make a condition on the group by and restrict that to a particular case. And for instance, here we want the department name where all the salaries are greater than 42,000. So all the instructors who make 42,000 in a particular department are now listed. Okay. Now I was telling you how SQL is a non-Turing complete language. Now, when you want to have all the other commands like procedures and functions, you can make the application program in Java or C# to work with a database, okay? And to work with C# and Java, you can embed SQL to perform queries, select statements. That's called embedded SQL. But when you actually work with a database, you need a driver. Like Java needs JDBC, C# needs ODBC, such as ADO.NET. Okay. Okay, so here's some Visual Basic code which works with SQL Server. You see, okay, here is some C# working with SQL Server. Okay. Now I want to basically go through an example which is very useful. Okay. Let's say we want to design a bunch of tables, a relational database with information about weather, observation stations, where the weather station and where it's located and what happens with what's the temperature there, and et cetera, whether there's rain there, et cetera. Okay, so as you saw from before, this is a data definition language. So we create the table. We create the table station, and we have put in the fields. ID is integer, city is character, state, and latitude, north, longitude, west, real. And we have a constraint that the ID integer is the primary key. Okay, so what do? We populate the table station with a few rows. Insert into station values 13, Phoenix, Arizona, 33, 112, longitude. Insert into station values 44, that's the ID, the city, the state, Denver, Colorado, 40 and 105, longitude. Insert into station values 66, Caribou, Maine, 47, 68. And voila, this is your table. Okay? Now, let's say we want all northern stations where the latitude north is greater than 39.7. So we want to get all the columns. Getting all the columns, again, is that select star. So we select star from the table station, which we just created, where the latitude is greater than 39.7. We perform this query, and we get this result set. Okay? You see city, state, latitude, longitude, and the ID. Okay. Now, let's say we want only the ID from station. We only want the ID, city, and state columns. So this is called a projection. We select ID. We want ID, we want city, and we want the state from the station. and voila, this is what we get, city, state, ID. Now let's say we want to restrict, to have a restriction. We select ID, city, state from station where the latitude is greater than 39.7. So this is a restriction from the query, and this is the result. Okay, let's say we want to create yet another table and have that table have some information which is related to our first table, the station table, and then to join them and to get information from both tables. So let's say we create another table to store normalized temperature and precipitation, rain data. ID field must match some station table, so name and location will be known. Okay, allowable ranges will be enforced for other values. No duplicate ID in month combination. Temperature is in degrees Fahrenheit. Rainfall is in inches. So what we do, we insert into stats values. We insert. Okay, this is create a table and we insert into it various values. Okay, and let's take a look at what's been populated into that stats table. So let's start, which gives us all the columns from that table, and voila, here we have a new table populated with information we entered into the insert statement. Let's look at the query. Let's perform a query to look at the table stats, picking up the location information by joining that table stats with the first table station on the ID column. Matching the two tables at a common column is called a join. The column is often matched, but this is not required. Only the column values are required to match. So we select from station the first table with the second table stats, where the station ID equals the stats.id. Remember, we place a primary key from station into the second table stats to form a foreign key, and that's the primary key of station. First I have to back up a second. I'm going by very quickly, and the classes will be much slower, and we will do a lot of examples. I'll print out examples, all kinds of examples, but this is to give you an overview of the course. So I'm moving rather quickly, so do not be discouraged if this is going too quickly. And this PPT will be available to you to look at, okay? I will always do that for my classes. Okay, so here we go is the select results statement. We get the two tables joined together, so we have the fields ID, city, state, latitude, longitude, ID, month, temperature, and rain. Now let's say we want to perform a query to look at table stats ordered by month and greatest rainfall with columns rearranged. So we select from the stats the various columns, month, ID, rain, and temperature, and we want to sort it by month. We sort first on month, and then within the month we want to sort by the rainfall in descending order, okay? And that would be like this. The result set is this, okay? Okay, let's do a join again. Query to look at temperatures for July from the second table stats, get the lowest temperatures first, picking up city name and latitude by joining with the first table station on the ID column. Okay, so you do select lat, city, temp from stats to second table, the first table, station where the month is 7, and the stats ID equals the station ID, order by the temperature in Fahrenheit. And you, voila, here's what you get. Let's do a query using the aggregate functions, max and min, and average. Here's a query to show max and min temperature, as well as average rainfall for each station. So we select maximum temperature, the aggregate function, over all the temperatures, and min over all the temperatures, average the rainfall, and get the ID column back to from stats, group by ID. And voila, here is your result set. Now, remember data manipulation is not only done through queries, but you can update, insert, or delete. That's data manipulation. So let's say you want to update all the rows of the table stats to compensate for faulty rain gauges known to read 0.01 inches too low. So what you found there was a mistake. rain was read too low. You have to update everything by 0.01. So this is what you do. You update this table, set the rain field equal to rain field plus 0.01, and you select from stats, and voila, here's your result set. Okay, so that is SQL. Now, SQL has been around for like 30-some years. So is it going away? How long will it be with us in the next 20 years? That's kind of hard to tell, but SQL has had staying power. Why is SQL so important? Well, people have tried to move away from SQL through a no-SQL movement. Carefully, over the past 10 years, we moved to even bigger data. There's been explosion in data. It's big data. You've heard of that, right? Big data. Now, initially, no SQL meant we were just going to move forward from SQL and not use SQL anymore. To graph databases, key value databases, document store databases, or column value databases. However, we couldn't do that. SQL has too powerful querying. The query feature of SQL is too powerful and too efficient that you just can't get rid of SQL. So for even big data, we have some languages, some databases still using variants of SQL. So instead of no SQL, no SQL now stands for not only SQL. A number of new SQL relational data stores are gaining acceptance, including VoltDB. So you have to support queries with SQL. SQL is standard. Why is SQL so good? It's easy to find people who already know SQL. There's a lot of resources available to learn SQL. SQL is declarative. Applications are much less fragile, and they tolerate changes to the underlying columns. SQL scales. Many NoSQL stores have added SQL or SQL-like query language without crippling performance. Maybe some of you have heard of Hadoop. It's a big data solution where you process a lot of data on top of a database management system. It's big data. And even Hadoop uses SQL. It's actually called Hive, and also uses Pig, which is also a little bit like SQL. It uses two types of query languages, which are reminiscent of SQL. Okay, SQL is flexible. Vendors and open source projects have liberally extended SQL. Oracle, the famous relational database company which I worked at, allows users to run SQL queries against Hadoop data stores. More SQL players may go down this route in the future to appease customers of both worlds. Actian and IBM offer SQLization of Hadoop. Combination of NoSQL and SQL is probably the future. So SQL is still important. It's not going to be just NoSQL. It's going to be NoSQL and SQL. They talk of a three-pronged approach. The first two prongs are existing applications continuing to use SQL. And then new applications deal in unstructured data using NoSQL database. So it's three-pronged. Two-pronged of SQL and one prong of NoSQL. I want to thank you for taking this webinar. This concludes the initial teaser. I welcome you to take my classes. I also will actually do something that maybe a lot of instructors don't do. I get about 5 to 10 job postings to recruit me almost every day. Every week I will put up a job board for my class. And then you can search this job board, and we can match you up and see if you could fill the position. If not, we'll see. I have 20 years of software engineering experience. I can tell you what you're missing, and you can take that to UCLA Extension. Thank you very much.
All right, thank you. And if you have any questions, please let us know. And again, you can type your question on the chat box as well. Okay, all right. If I guess we have been I've been typing and responding to the chat box some of the different type of questions related to the courses and so forth. And so why don't I turn it over and to Venise and our program manager, and that she gonna basically give you a little flavor of what kind of courses and the certificates that we offer, and and I'll take you through that.
Thank you, Bruce. First, I'd like to thank Ray for that wonderful presentation. I hope everyone has found it interesting and useful and helpful. As Bruce mentioned, my name is Venise Crawford, and I'm a program manager here at UCLA Extension in the Department of Digital Technology. So if you are interested in what you've seen so far today, you might want to think about enrolling in our Introduction to SQL course that's coming up in the spring quarter, which starts on April 3rd. In addition to our Intro to SQL courses, we have a ton of other database and data science related courses. They include, as I mentioned, Introduction to SQL, Advanced SQL, Relational Database Management, Advanced Database Management Concepts, Introduction to PHP with MySQL, Microsoft SQL Server Administration, Programming Microsoft SQL Server, and for some of our data science courses, Intro to Data Science, we also offer Hadoop in managing big data analytics, and data governance. So all of these courses can be taken individually, but they can also be applied as electives to our computer science certificates. And as you'll see here, we offer a variety of certificates ranging from applications programming, information system security, systems analysis. But the courses we're talking about today are particularly relevant to our database management certificate. So I'm going to show you how to enroll in this certificate later, but for now, I'm just going to walk you through the steps on how to enroll in an individual course.
Don't really have to
before I show you how to enroll in this course, I also want to talk about some of our certificate benefits. So as a certificate student, the main benefit is receiving a UCLA Extension Gold Seal certificate. This is a hard copy document that you'll be able to take with you on job interviews. You'll be able to list it on resumes when applying for various jobs, and the UCLA Extension name is very well respected, not only throughout Los Angeles, but throughout the country. You will also be able to get a Bruin card. As a Bruin card holder, you will get access to various discounts, such as discounts on bus fare, discounts on software from the UCLA Computer Store, and access to various UCLA sporting events and social events. As a certificate student, you'll also get access to Career Spot and Bruin View. These are both online career tools that will help you prepare resumes, help you prepare for interviews, and they also give you access to job postings exclusively for Extension students. Another important benefit is the access to the UCLA Alumni Network. So how do you enroll in an individual course? The first thing you're going to do is visit our homepage at uclaextension.edu. The easiest way to find an individual course is just to simply type it in the search courses search bar. And for purposes of demonstration, I'm going to show how to enroll into Introduction to SQL. I've typed the course title in the search bar. You hit enter. And then you will navigate to this page from where you will click on the blue course link. Once you click there, you'll be taken to the course page. You'll see a course description on the left side. You will also see a link to view the course syllabus. And on the right side, you will see that we have both online and in-person sections available for spring enrollment. For this demonstration, I'm going to enroll in this class here. So if you click anywhere in this square, that will take you to the course details for that particular section. Again, you'll see the course description, some highlights of the class, and then on the right side, you will see all of the scheduling and various logistical information. As you see here, this particular section meets in person starting April 4th on Tuesdays from 6:30 to 10 p.m. If you want more details on exact building and room location, simply click the View Details link. So once you've found the section that suits your schedule and that's a section you've decided on taking, you simply click the yellow Add to Cart button. And once you've clicked this button, you'll be prompted to set up a student account if you don't already have one. And you will also be prompted to pay the course fee. Once the course fee has been paid, you are officially enrolled in this course and ready to go when it starts April 4th. So now I will go over how to enroll in a certificate. It's very similar to enrolling in an individual course, only a slight difference. So again, you want to navigate to uclaextension.edu, and on the left side of your screen, at the top left corner, there's a Browse button. You'll hover over that Browse button, and once that drop-down menu appears, simply go ahead and click Computer Science and Engineering, right there. And then you'll click Computer Science and Information Systems on the left side of your screen. And this will take you to the various certificates that we offer. Again, we offer many different certificates, but for purpose of demonstration, I will show you how to enroll in the Database Management Certificate. So if you decide that this is the certificate you want to pursue, you can go ahead and click that certificate title, and you will be taken to the certificate page. You see a brief description of the certificate. You see my contact information listed on the page as well, and you see a breakdown of the estimated cost. On the right side, you'll see a list of required courses, and as I mentioned earlier, any of the database or data science courses we've discussed today can be applied as electives to the Database Management Certificate. So if you say to yourself, you're really interested in database management and you want to further your knowledge in that field, I would suggest enrolling in this certificate and completing the entire program. And to do that, you simply click the yellow Apply Now button. And once again, you'll be prompted to create a student account if you don't already have one, or log into your student account if you do have one. And then you'll be prompted to pay the certificate fee of $150. So that concludes the enrollment information. If you have any questions at all, feel free to contact me directly. My email address is crawford@uclaextension.edu. My phone number is 310-825-0213. You can also contact my colleague, Damar Douglas. His email address is ddouglas@uclaextension.edu, or you can give him a call at 310-825-7609. We also want to hear your feedback. So any feedback that you have, we would love to hear from you. If there are any other topics that you want to see covered in a webinar like this, please let us know. We're very excited to improve our program and see what you all are interested in, and we'd love to hear from you. So once again, thank you for joining us, and have a great day.
Thank you very much. And again, I have been answering a number of questions on the chat box, and yes, this webinar is recorded, and yes, we will be sending the link out to everyone that who participated, and so that you can review the webinar. And again, if you have any questions need to have us follow up with you, and please contact again Venise or Damar, and with their contact information on the screen at the moment. And well, thank you for taking the busy time out of your day and joining us for this webinar. And so we Wish you have a good afternoon, and thank you very much.